Hello students, today I am going to take a new topic from surface chemistry, that is factors affecting adsorption of a gas on a solid. Here gas act as adsorbate and solid act as adsorbent. Okay, first factor, nature of gas means nature of adsorbate. Second factor, nature of adsorbent. Third factor, effect of temperature. Fourth factor, pressure. And fifth factor, specific area of adsorbent. And sixth factor, activation of adsorbent. Okay, today I am going to discuss the first three factors which affect adsorption of a gas on a solid. Okay, let us study the first factor, that is nature of gas, means nature of adsorbate. There are two types of gases. Okay, the gases having high critical temperature. Tc is the symbol of critical temperature, and the gases having low critical temperature. The examples for the gases having high critical temperature: ammonia gas, SO2 gas, etc., having carbon dioxide gas, etc., having the gases having high critical temperature, and the gases having low critical temperature: hydrogen, oxygen, nitrogen, etc. Already we studied the chapter states of matter. The gases having high critical temperature can be easily liquefiable. This gas can easily liquefied. Okay, the gases having low critical temperature cannot be easily liquefied. These gases are called permanent gases. Okay, scientists experimentally shows that the gases can be easily liquefied are more readily absorbed. That is, the gases more easily liquefied can be more readily absorbed. Okay? That is, gases having higher critical temperature are absorbed more than that of the gases having low critical temperature. Okay, the more easily liquefiable gases like ammonia, SO2, CO2, etc. are readily absorbed as compared to the gases having hydrogen, oxygen, nitrogen, etc. Okay, the second factor, nature of adsorbent. The extent of adsorption also depends upon nature of adsorbent. Activated charcoal, finely divided finely divided transition metals, finely divided platinum, finely divided chromium, finely divided nickel, etc. are good adsorbents. Finely divided transition metals, etc. are good adsorbents. I already told you the extent of adsorption depends on nature of adsorbent. Scientists experimentally proved that this activated charcoal is the good adsorbent for easily liquefiable gases. Easily liquefiable gases like ammonia, SO2, etc. These easily liquefiable gases are highly toxic. Hence, charcoal is used for the manufacture of gas mask. Charcoal is the good adsorbent for toxic gases, that is easily liquefiable gases like ammonia, SO2. Hence, charcoal is used in the manufacture of gas mask. Very important point. And this second one, finely divided transition metals are good adsorbent for permanent gases like hydrogen, oxygen, nitrogen, etc. Yes. The third factor, temperature. Okay. Let us study how temperature influences extent of adsorption. Actually, the term X by M indicates, this term indicates extent of adsorption. Extent of adsorption, X by M. Extent of adsorption. Here, X indicates what? X by M indicates extent of adsorption. X indicates mass of adsorbate, and M represents mass of adsorbate. That means we know the mass of adsorbent always remains constant, but the mass of adsorbate, that is gas, increases during the process of adsorption. That means when the value of X increases, when mass of adsorbate increases, this X by M increases. Okay. Yes, already we studied the adsorption of a gas on a solid. The process of adsorption is exothermic. Then, according to Le Chatelier's principle, when temperature decreases, X by M, extent of adsorption, increases. According to Le Chatelier's principle, when temperature decreases, exothermic reaction increases. Since the process of adsorption is exothermic, when temperature decreases, the extent of adsorption increases. Gas adsorbed on a solid, this process is exothermic. Gas adsorbed on a solid. This process is exothermic. Okay. Gas adsorbed on a solid. Since the process of adsorption is exothermic, okay, please listen, when temperature decreases, the extent of adsorption increases. But this variation is different for physisorption and chemisorption. Okay, then we can draw a graph plotting between x by m and temperature at a constant pressure. The graph is drawn between x by m and temperature. X by m versus temperature graph at a constant pressure. At a constant pressure, this graph is called adsorption isobar. Adsorption isobar. Yes. First, we can study how temperature influences the extent of physisorption. Okay. In the case of physisorption, x by m versus temperature graph is obtained like this. This graph is called physisorption isobar. Yes, this graph is called physisorption isobar. Physisorption isobar, very important graph. From this graph, we can say that, by observing the graph, we can say that when temperature decreases, extent of adsorption increases. Or when temperature increases, extent of physisorption decreases. Okay. Actually, the force of attraction between adsorbent and adsorbate in the case of physisorption is weak van der Waals force. Then when temperature increases, the kinetic energy of gas molecules increases. The kinetic energy of gas molecules increases. Then the adsorbate molecules can easily leaves out from the surface of adsorbent. Okay, that means extent of adsorption, extent of physisorption decreases with the increase in temperature. Yes, this graph indicates chemisorption isobar. In the case of chemical adsorption or chemisorption, when temperature increases, extent of adsorption, that is x by m, increases in the beginning. Please listen. Then at a particular temperature, the value of x by m becomes maximum. X by m reaches a maximum value. Then x by m decreases. Okay. Already we know chemisorption, just like chemical reactions, some activation energy is required for chemisorption. Okay. Yes, this is the reason behind this initial increase. Some activation energy, some extra energy is required for chemisorption. Okay, chemisorption, already we know chemisorption. In the case of chemisorption, some chemical bonds are formed between adsorbate and adsorbent. Hence, chemisorption does not take place at low temperature. That means when temperature increases, x by m increases at a particular point, x by m reaches a maximum value, and at this point the molecules possess its maximum, x by m reaches a maximum value. At this point the reactant molecules possess, that sort of molecules possess maximum, that sort of molecules possess, the adsorbate molecules possess maximum kinetic energy. Then if the temperature increases again, the adsorbed molecules have the tendency to leaves out from the surface of the adsorbent. That means when temperature increases, x by m decreases. Okay, please listen again. In the case of chemisorption, when temperature increases, x by m increases at a particular point, x by m reaches a maximum value. Okay, the reason is that chemisorption, just like chemical reaction, it requires activation energy. It does not takes place at a lower temperature. Then when temperature increases, x by m increases, it reaches a maximum value. Then if it increases the temperature again, x by m decreases. Okay, my next video we will discuss the remaining three factors, that is pressure, specific area of adsorbent, and activation of adsorbent. Okay, goodbye.